would send it to channel 2, and my channel 2 would do the needful. I would send my data to printer and it would be displayed. So how easy the flow is, and this is known as output spooling because we are spooling the data into output, that is console or printer. So let's recap the flow of data. Suppose I have to perform input operation, that is read data from somewhere and take it as an input. So suppose my input device is card reader, so it would be sent to channel 1. Channel 1 would load the data into buffer. Buffer would send it to empty queue. Empty queue would send it to input queue. After sending it to input queue, we know that input queue would be sending that data to channel 3. And after it gets loaded into channel 3, it all depends upon what we have to perform. If we have to perform some operation on the data that we have received, it would go to main memory and CPU would be coordinating with each other. Or else we can directly store it into the drum that we have. But what if we have to perform a particular output operation? And in that case, we know that our data is in drum. Our data is in drum and we are going to load it into main memory. After loading it into main memory or channel 3, what we are going to do is we are just sending that data to out empty buffer or empty queue, and empty queue would load it into output queue. Output queue would send that data into channel 2, and channel 2 would print it into console. And always remember that whenever input queue is going to load data on channel 3 or output queue is going to load data on channel 2, in both of the cases what would happen is the data of that input or output queue would be freed, means it would be released, it would not be backed up by these queues, right? Now the important point is, how do these three channels coordinate with each other? Means, how is the coordination happening among each other? Because we have three channels, we can have a lot of mechanisms that can allow us for coordination. But for coordination, what we are using is IOI, that is input output interrupt. And just before starting IOI, I want to tell you something about the time taken by channel 1, channel 2, channel 3. So channel 1 takes 5 units of time, channel 2 takes 5 units of time, and channel 3 takes 5 units of time itself. But more importantly, channel 3 is involved in a lot of operations, be it input spooling, be it output spooling, be it in get data operation or put data operation. Right. So let's see what happens in IOI. So input output interrupt allows us to know which channel is busy and which channel is free. So always remember that suppose I'm starting my system, so no channel would be busy, right? Everyone would be free. So in that case, something would be different, some state would be different. Suppose I'm reading the data. So in that case, channel 1 would be activated, right? Now suppose I'm writing the data, channel 2 would be activated. And suppose that I am doing these operations simultaneously, then both of the channels would be activated. And in these intermediate states, most probably channel 3 may be activated also. Not 100%, but there are chances that it would be activated too. It would be busy too. So what to do in that case? Then what we do is we utilize IOI, that is input output interrupt. So always remember that IOI has 1, 2, 3, 4, 5, 6, and 0. These many states, or maybe one more, we would see this. Suppose 0 means all are busy. Sorry, all are free. I'm not writing it up right now, but you have to remember this. 0 means all are free. 1 means channel 1 is free. Sorry, channel 1 is busy. 2 means channel 1 and 2 are busy. Just wait a second. Rather than just saying this, let me write it here. This is channel 3, channel 2, channel 1. Now, in case of 0, this would be the sequence. I know that. Sorry, this would be the sequence. All of my channels are free. But in case of 1, I'm just activating channel 1's bit. Now I know that in if IOI value is 1, then in that case my channel 1 is busy. If IOI value is 2, my channel 2 is busy. If IOI value is 3, my channel 2 and channel 1 are busy. If IOI value is 4, then in that case I know that my channel 3 is busy. If IOI is 5, in that case my channel 3 as well as channel 1 is busy. In IOI equal to 6, this is the state where my channel 2, channel 3 are busy. And in 7th state, everything is busy in my system. I have no way to escape right now. So, what does it mean? If IOI value is 0, I can perform input operation, I can perform output operation. There is no issue in it. What if my channel IOI value is 1? In that case, I cannot perform input operation because my channel 1 is busy. In case 2, where CH2 is activated, in that case I cannot perform output operation. In case 3, I can neither perform input nor perform output. But, and when I say but, it means a lot because channel 3 is free. So we can perform some operation in nearby future. In channel 4, we know that, in fourth case, we know that CH3 is activated. Fifth case also, sixth case also, seventh case also. So in that case, we cannot utilize our most important channel that we have, right? And that's the concept of phase 3. And how do we change these values? That is very important point. So for changing this value, suppose I have 0 0 0 as the states within my system, 0 0 0, and suppose my channel 1 is getting activated. So just perform OR operation upon existing IOI value 0 0 1. What would it result in? It would result in 0 0 1 itself. Now suppose my channel 2 is getting activated 0 1 0. Now what would be the output? 0 1 1 would be my output. Suppose now I am performing operation on channel 3 1 0 0. Now 1 1 1 would be my output. So this is the manipulation that we are talking about. So for synchronization purpose, channels are introduced where each channel consumes 5 units of time, and they coordinatingly allows us to perform different operations at same time simultaneously, so that we can increase the speed of our system and we can perform multi-programming.